Alright, we're going to talk about geometric means. So we're looking at this kind of figure. This is the kind of figure we're going to deal with in this whole section here. It's a right triangle, ACB, with an altitude, meaning it goes from one angle to the opposite side and it's perpendicular, makes right angles. So we have three right angles, the blue one, the green one, and the whole big one. I'm going to call the blue one the medium-sized one, and the green one the small one. So prove ABC, the big triangle, is similar to triangle ACD. Well, if we redraw them, kind of straighten them out, all I did was kind of turn ACD to the right, and it looks like that. Well, we know angle A is congruent to angle A. They both have angle A. They overlap there. And then they both have a right angle. In the big triangle, it's ADC. In the medium triangle. In the big triangle, it's ACB. So those angles are congruent because all right angles are congruent. So by angle-angle similarity, the triangles are similar. So we write our ratios. AB, first two letters. AC, first two letters. AC, first and third letter. AD, first and third. BC, second and third letters. CD, second and third letters. So we're going to do that same thing with the big triangle and the little triangle. The big triangle, still like that. The little triangle is really exactly like it looks. It didn't have to, I just redrew it. Again, angle B is congruent to angle B. They share angle B, so they're congruent. And then again, they both have right angles. Angle ACB and angle CDB are right angles, so they're congruent as well. So by angle-angle similarity, the two triangles are similar. And we can write our proportion. First two letters of the first triangle, AB, over the first two here, CB. Then second and third, CB, over BD. And I switched them around for a reason. Then AC, first and third letters, goes with CD. Then why is ACD similar to triangle CBD, the small and the medium? Really because of transitive property. If they're both similar to the big one, they have to be similar to each other. So we can write our statements from that as well. AC goes with CB, AD goes with CD, and CD goes with BD. So we have all of our measurements here. And I put squares around the ones where you saw the same thing twice. We had CD twice here, CB twice here, and AC twice here. It's a geometric mean. What a geometric mean is a number that fits in between two other numbers in a true proportion. Or it's a square root of the product of those two numbers. So 2 would be our geometric mean. It's in between two numbers in a proportion that's true. 1 over 2 is 2 over 4. I could cross multiply and check it. 4 times 1 is 4. 2 times 2 is 2. So that makes sense. 6 is a geometric mean between 3 and 12. 3 times 12 is 36, and 6 times 6 is 36. So if we wanted to find the geometric mean between two numbers, 4 and 16, the x's go in between. Cross multiply, 16 times 4 is 64, x times x is x squared. Take the square root, we get plus or minus 8, and it can be plus or minus 8. So that's what I'm saying. This last way is really looking at this second definition, the square root of the product of two numbers. So what we're going to be dealing with in the geometric mean of two legs and the altitude of the big triangle. So we're always just going to be looking and kind of setting up formulas for A, B, and H. So there's two ways to think about it. We can set up the proportions like we did up here, but I think the easiest way to think about it is that A, so we're going to start all of our lines from our big right angle of the big triangle. Then A, from C we go to letter B, so that's A, and from there we can go two places. We can either go to D or we can go to A over here, so that's that light blue. So A is a geometric mean in between those two distances, in between x and the whole thing, which is c. So A is between x and c. Or a leg squared equals a hypotenuse times the part of the hypotenuse. So A times the whole hypotenuse, C times the part, x. We do the same thing with B over here. We start from angle C and we go to A. So B is going to be the geometric mean between, well, from here we can go to D, so that's segment Y, or we can go all the way to B, and that's segment C. So B is in between Y and C. We cross multiply those, we can see that our leg squared, B squared, is equal to the hypotenuse times the part. But now it's the part on the same side as B. It's kind of like our angle bisector theorem. So these are both the same. Then we can do the same thing for our altitude, h here. From C we go to h, and we have two positions. We can either go to the left, using x, or we can go to the right using y. So h is a geometric mean between x and y, or the altitude squared equals part times part. So we'll be looking at both of those. On your papers, I had to change some. I copied it and made it wrong. So y should be the first one here, and x should be here, and down here, y should be here, and x should be here as well. Just like what we wrote up here, but we got to fix it here. So if we do some problems, we want to find x, so we're going to find this side. So if we start at our right angle of the big triangle, it goes to here. So x is going to be our geometric mean. It's going to be in between two numbers. And it's going to be in between, well, we can go to 36, or we can go all the way over to here, which is 36 plus 64, so 100. So x is in between 36 and 100. So we cross multiply, square root, we get 60. And we can't get negative 60 because we can't have a negative distance. And the distance is here. So here, I'm going to do the other method. The altitude squared equals part times part. So altitude is x squared equals part 9, so we did 25 minus 16, times 16. So x squared equals 144, takes a square root, x equals 12. So that's the formula part. This is the proportion way. Another proportion. We want to find this x, so we're going to be using the 12, our altitude. So from the right angle of the big triangle, we go here. So 12 is going to be in between the two numbers, so it's here. And what number is going to be in between? Well, we can either go to x or we can go to 9. And you could flip those 9 and x. They can be in the different spots. But it's x over 12 equals 12 over 9. Cross multiply, 9x equals 144. Divide by 9, x equals 16. Same thing here, but now again I'm going to use the formula. The altitude squared, 48 squared, equals part times part. So 48 squared times 36 times x is 2304 equals 36x. Divided by 36, x equals 64. Here, we want to find this part. Well, we don't know anything about this leg, the one that I'm dragging over, so we have to use this leg. And we don't know anything about the altitude either, so we have to use the 60. So the 60, the leg, is going to be in between two numbers. Well, if I go down 60 from the right angle, I can either go 36, or I can go all the way here, 36 plus x. And those are going to be my two numbers there. So 36 over 60 equals 60 over 36 plus x. Cross multiply, subtract 1296 from both sides, divide by 36, x equals 64. Here, another formula, it's our leg squared equals part times the whole hypotenuse. So leg squared, 15 squared, equals the whole hypotenuse, 9 plus x, times the part, 9. So we distribute the 9, get 225 equals 81 plus 9x, subtract 81, you get 144 equals 9x, divide by 9, x equals 16. Alright, we have the same thing down here, but now we have a word problem. We need a bridge. We need to figure out this distance here. Well, we know this distance and we know this distance, but one's in yards and one's in feet. We got to have the same. So it's easier to change from yards to feet, although I guess we could have done feet to yards. But 45 yards, we multiply by the conversion rate. 35 yards times 3 feet over 1 yard, because 1 yard is 3 feet. And when we do that, the yards cancel out and our units are feet, and that's what we want. So 45 times 3 is 135. So 45 yards is 135 feet, so I'm just labeling now. This is 135, this is 130. So again, we can travel from our right angle of our big triangle. So 130 is going to be between the two directions I can go. 130 is going to be between 135 and x, and that's what we have down here. Or we can just remember the formula, the altitude squared, 130 squared, is equal to part times part, which is what I did here. Either way, you're going to get the same thing, and x is about 125.19 feet. And that's our geometric mean.